Right, so like I said, you have to remember to double your p-value. You're still going to compare it to a set level of 0.05. Plan as conditions are met, we'll do a one-sample t-test for mu. It's random, we know that. The normal, yes, n is greater than, is 50, which is greater than or equal to 30, so the sample is large enough, so it's okay to use T procedures. And then independent, 500 pineapples in the field, because of sampling without replacement, we would expect that if it's a large field, there'd be more than 500 pineapples in it. The due, so again, we have the mean and the standard deviation they gave us in the problem, I think. Let me get back and check. I have the Minitab output. Here it is. Here's the mean, and they give you the standard deviation. So we have that. Again, the mean minus the null divided by the standard deviation divided by the square root of n gives me my t statistic of 2.762. If we have 50, our degrees freedom is only 49. Okay, so you're going to have to round down to 40 to be more conservative because our chart jumps. And then notice that a t statistic of 2.762. They'll show you 2.762 is between these two, which is between 0.005 and 0.0025 probability in the tail. And that's one side, so you would actually have to double it. It's even with it being doubled, so then it's going to be between 0.005 and 0.01, which is still less than the alpha significance level, so we have enough evidence to reject H0 and conclude that the mean weight of the pineapples this year's crop is not 31 ounces. If you use a T statistic, you get it from, and use the calculator, and you don't want to use the chart, you can always just tell me what your T statistic is and plot it on a curve. So you would draw your curve, and you tell me that it has a degrees freedom of 49, and you plot it at 2.769, because that's your value, but remember it works at the negative 2.769, and this here and here, and you're going to actually do an inverse T, or sorry, T CDF for the area under the curve, and like I said, you can either find this and double it, so I could go from lower bound of a negative infinity to an upper bound of negative 2.769. And then it's going to ask me for degrees freedom, which we already said was 49, and it'll give you an exact p-value for yourself here. And then that p-value, all you have to do is double that value for yourself. All right, so I need to find this p-value, so I can go to my calculator and I can do menu, statistics. I can go to distributions and just TCDF. And my lower bound's a negative 9e to the 999, and I'm going to go to negative 2.7, I think 96. Let's look real quick. 2.769. And then you have to tell the degrees freedom, and we have 49 degrees freedom. And so the calculator will actually give you the exact values. So then we have a p-value of 0.003959. And so I can go up and capture it and say, oh, I need to double it because I have a two-tailed test, which makes my p-value 0.007917. So here I would say my p-value is equal to 0.00719. And then that is still less than my accepted alpha at 0.05, so I'm going to get to reject the null. Now remember that my calculator from the beginning would have done the whole thing for me again. I'm going to show you again so you see it that it's in the stat test, t-test. Now we don't have data, this time we have statistics, and we click OK, and our null is that it equals 31. Our X bar was, let's take a look at the PowerPoint real quick. Let's go back to the Minitab output, which we don't have here. There it is. Mean is 31.935 and a standard deviation of 2.394. So we need to go here and put that it's 31.935, and the standard deviation, again, we'll look in that the standard deviation here was 2.394. So if I go 2.394, and my sample size was 50, and we got all that in the computer output, and the alternative is not equal to, so you click OK. Notice that they give me the same test statistic that I got. It gave me a p-value. It's a little bit different than the one I had, but it's still small enough. And so you have your p-value here. So you can just show where you got it and make your work look like you did it by making sure you draw the curve, you show how you'd get a t-statistic, and so forth, and making sure they know that you have the degrees freedom in there. So that is that.